Hi everyone, let's take a look at problem 1. I'm going to apologize right from the start. My dogs are very full of it this morning and you'll hear them running around and playing and growling, so I'm sorry. I hope it's not too distracting. But anyway, problem 1, this is the cardboard cutout that I showed you in the last video. And so we need to find the center of gravity, or the centroid. So there's several steps in doing these problems. And let's take a look at this first problem and see what we can do as far as figuring out the steps. So it says the first thing we need to do is subdivide the area into simple shapes and compute its area. So I can subdivide it this way and this way. And so now we have 3 rectangles. And so now it wants us to compute its area. Well, the top rectangle is 4 plus 4 plus 2. That's 10 inches by 4 inches. So 10 by 4. And the middle one is 4. And if we read up here, the width is going to be 4. And then the last one is 10 by 2. So 10 by 2. And so we would end up with, 40 plus 16 plus 20 is 76 square inches for our shape. So the first thing we need to do is subdivide this so we can find the area. Okay, the next thing we do is we need to choose where to place the x and y axes from which we will measure the coordinates. Okay, so the problem doesn't tell us where to put the axes. And so we can put the x and y axes wherever we want. And we want to do that so everything, is easier for us. And so what we can do is put the x-axis across the bottom and the y-axis across the left side. And so our entire shape fits in the first quadrant, so everything's going to be positive. Okay, so I chose to place them here and here. Some of the problems will tell you where to place the x and y axes. Other problems will let you choose. Okay, next, we need to find the centroids for each of the 3 smaller regions. And so if we look at this top rectangle, well, we know from the top picture that this is 10 and this is 4. And so left or right, we go 10 units. And so the middle will be at 5 units. So our x-coordinate would have 5. Well, this height here is 4 inches. So halfway in the middle would be 2 inches. But remember, our x-axis is down here. So we have to go up the 2 inches, up 4 more, and then up the 2 inches that we found. So 2 and 4 is 6, and 2 more is 8. So our y-coordinate would be 8. Okay, so we have the centroid in the top region of 5, 8. Okay, the middle rectangle, it's actually a square because we know this is 4 inches and this is 4 inches. And so left or right, we go 2 inches for the centroid since the whole thing is 4. But remember, our y-axis is here, so we need to go over 4 inches and then 2 more. So that'll give us 6. Do you guys see that? We need to go over this distance, and then from the top picture, we can see that that's 4 inches. And then to get to the centroid, we have to go over 2 more. So 4 and 2 is 6. Okay, now vertically. Well, we know this length here is 4, so in the middle would be 2 inches. But we have to go up 2 inches here and then up another 2 inches. And so we'd have 2 and 2 is 4 for the x-coordinate. Okay, and then the bottom rectangle, which is probably the easiest one. We know this length is 10, so left to right, that's 5, and we start at the y-axis, so we don't need to add anything, so it's just 5. And then here we go up or down 2, so halfway in the middle is 1, but the bottom side is along the x-axis, so we don't need to add anything. So it's just 5, 1. Okay, so just to recap, the first thing we did was we divided this into regions and found the area. And then the next thing we did was we placed our x and y axis and found our centroids of the smaller areas. Okay, now we get to do some fun math, and it's going to seem a little weird, but this is how we figure out the centroid. So next we find the moments for the x and y axes. So the moment for the y-axis actually deals with the x-coordinates because you're talking about the moments about the y-axis. And so, you know, from the y-axis, we're going to go over x units. So the moments for the y-axis is area times distance plus area times distance plus area times distance because we have 3 regions. And so we have to take them all into consideration. So the area of the top region was the 10 by 4, so 40, times the x-coordinate for the centroid. And so that was 5. And then plus, let's go on to the middle square. The area was 16 because it was 4 by 4. And then the x-coordinate is 6. And then for the third rectangle, we have our area is 20 and our distance would be 5. So it's 5 away from the y-axis. And so you plug that into your calculator and you end up with 396 square inches. Whew. Okay, almost there. We need to do the same thing for the moments about the y-axis. So we're actually going to pick off the y-coordinates because the y-coordinates tell us how far from the x-axis that we are. So top rectangle, we know that was 40, and then the y-coordinate, that's the distance from the x-axis, is 8. And then for the middle one, the area was 16, and then the distance to the x-axis is 4. And then plus, for the bottom one, our area is 20, and then our distance is just 1. So type that in your calculator and you get 404 square inches. Whew. Last step is we need to take these moments that we found and divide by the area of the region, which is, we found the whole region to be 76 square inches. Okay, so the moments about the y-axis is 396, and we divide by the area, which is 76, and that's actually going to give us our x-coordinate. Because remember, the moments about the y-axis, that tells us our distance, and it would be our horizontal distance, so that would be our x. And so 396 divided by 76 is about 5.21 inches. And then we do the same thing for the y-coordinate. Well, for the y-coordinate, we want the moments about x. So that would be 404 divided by 76 is 5.32 inches. So what the heck does that mean? Well, if you come over 5.21 inches and you go up 5.32 inches, that would be your center of gravity. So if I got my little piece of cardboard out and I measured over 5.21 inches and up 5.32 inches from the origin, so I'd end up here, and that's where the center of gravity is. Okay, let's stop here and go on to the next video.